Bismillahirrahmanirrahim. Allahumma rabbi zidni ilma. Bismillahirrahmanirrahim. Assalamu alaikum. Welcome dear students in the subject of Internet Architecture and Protocols. It's Ghulam Yasin, lecturer in Computer Science, University of Education Lahore at DG Khan campus. So dear students, our today's lecture topic is Transmission Control Protocol or TCP. As you know that protocol is set of rules and regulations which are used for communication on any network. If we want to perform a specific task, then there must be a protocol which is used for that specific task. Let's suppose if you want to browse a website, then the hypertext transfer protocol is used on the backend. Likewise, if you want to transfer a file, file transfer protocol is used. And in the previous lectures we have studied about simple mail transfer protocol, post office protocol and so on. Likewise, transmission control protocol is one of the most protocol which is used for reliable data transmission. So normally data transmission must be reliable because our data is very important, our information is very important. So if the data will be lost, then we have to retransmit that data. So on the backend we have to use transmission control protocol for reliable data transmission. So in the coming slides we will study in detail about transmission control protocol. TCP introduction. Transmission control protocol is used for different purposes. So some of the main features of TCP protocol are discussed over here. First of all is process to process communication. Dear students, whenever we open any application like Microsoft Word, Microsoft PowerPoint, Microsoft Excel, VLC player or any other application for using some specific software, on the backend a process is created, and from one process to another process, from one application to another application, when data is transmitted, then TCP protocol is used for reliable data transmission. And likewise, this is also used for node to node and end to end transmission. What is node to node transmission? Node to node means from one device to another device, and end to end transmission means from source to destination. Second point, full duplex communication. When data is transmitted and received at the same time, when data is transmitted and received simultaneously, this is called full duplex transmission, and for reliable transmission, transmission control protocol is used. Next is connection oriented service. All services which are connection oriented, for that specific service, for those specific services, TCP is used. Stream oriented protocol. This is stream oriented protocol. It means stream of bytes will be transmitted at the same time. Next is segmentation. When a large file is divided into small parts, those parts are called segments. So this is used for segmentation, and this is datagram in IP layer. Because IP is unreliable protocol, so TCP is used for reliable communication with IP protocol. Utilizes buffers at both ends, flow and error control. Because this is used for reliable communication, so there must be flow and error control. And for reliability we use acknowledgement concept. So last point, TCP seeks to deliver a byte stream from end to end in order and reliably. So first of all is in order. In order means when one packet will be transmitted, that packet will be received, after that second packet will be transmitted, second packet will be received and so on. So data will be received in sequence and the reliability is must. So TCP is for reliable data transmission. TCP header. Dear students, as you know that header is compulsory for data transmission. So every protocol contains some portion with itself which is called header. So TCP header contains some fields which we will discuss briefly over here. Source port, destination port. You know that source device and destination device. While data transmission is from source, then source port will be used, and data transmission is received by destination, then destination port is received. Next is sequence number. Sequence number is used for fragments. When large data is being divided into small portions, those are called fragments, and every fragment contains a specific number that is called sequence number. Next is acknowledgement number. When data is transmitted from source to destination, destination will receive the data and will send acknowledgement to source, which means that the data has been received by destination and the source will transmit next frame or next packet. So this is called acknowledgement number. Next is TCP header length, which is total length of TCP header. Next is URG. URG is for urgent. This is a flag which is used to inform receiving station that certain data within the segment is very urgent. So this is used for urgent, and TCP urgent flag is set over here. Next is acknowledgement. Just I have told you that acknowledgement is used for the reliable data received by the destination. Next is PSH. This is basically push flag. Push flag is used to inform the receiving station that data should be pushed up immediately. Next is RST, which is reset. When the connection is broke and the new connection is being developed, then this flag is used. This is basically reset flag or reset the connection. Next is SYN, which is synchronization. This is used for synchronize sequence number, initiate TCP connection. Next is FIN. FIN stand for finish. This flag is used for stop data transmission or end of data transmission. This is used to finish the TCP connection. Next is window size. When using sliding window flow control, we use specific window size. For example, 1 to 7 frames. You have studied in computer communication and network about sliding window flow control. So this is a window size which is set. Next is checksum. Checksum is used for error detection. Next is urgent pointer. Urgent pointer, which is used for indication the priority base data processing. If the data is very important, then urgent pointer is used to process data on urgent basis. Next field is options. Options allows to make use of new enhancement recommended by engineers. When the engineer will develop any specific new protocol or new specification or any enhancement, this field is used. And the large organization Internet Engineering Task Force is used for this purpose. And the last one is data, which is optional. Basically, data is actual or payload or data or files which are being transmitted. TCP features. Dear students, as in the previous slides we have discussed that TCP is a reliable data transmission protocol, and for reliable data transmission, every segment, every byte which is transmitted must contains a specific number, and this is discussed over here. Numbering system, byte number. TCP numbers all the data bytes that are transmitted in the connection. So when the data byte is transmitted, every byte must contain a specific sequence number. Next point, numbering does not necessarily start from 0. This is very important concept that numbers are randomly generated, which is next point as well. TCP generates a random number between 0 and 2 raised to the power 32 minus 1 for numbering first byte. For example, random number may be 3423 for first byte, and if there are total bytes 5000, all these bytes must contain a sequence number. Numbering range 3423 to 8422. So these are randomly generated numbers, and randomly generated numbers may be any number, but every byte which is transmitted from sender to receiver must contain a specific sequence number. What is the benefit of this specific sequence number? If the specific byte or specific packet or specific frame or specific segment will be lost, then it will be very easy to retransmit that specific frame which has been lost. So sequence number is again used for reliable data transmission. TCP features or continue topic. Sequence number. Bytes are grouped into segments because when data is transmitted, byte or the collection of bytes are called segments. So collection of bytes is being carried as segments. Sequence number for each segment is the first byte carried in the segment, because every segment contains many bytes. For example, in one segment there may be 1000 byte, there may be 2000 byte, and there may be 3000 bytes, and so on. So every segment must contains many bytes, and every byte must contain a specific sequence number. So over here, these are again randomly generated numbers, so don't confuse about these numbers. These are randomly generated numbers. First number is 3423 and the last number is 4422. If we minus 4422, 3423, then there will be 1000. So there are 1000 bytes in one segment, or segment number 1. So these 1000 bytes will be carried a specific sequence number which will be start from 3423 and so on, and it will go up to 4422. And likewise, second segment is being 4423, third segment is being 5423, and 6423, 7423, and so on. So these are like numbers which are randomly generated, and these numbers are assigned to every byte, and multiple bytes or combination of bytes are put up in one segment. TCP features. Acknowledgement number. Dear students, as we have discussed in our previous slide, every byte which will be transmitted from source to destination must contain a specific number. Likewise, when the destination will send acknowledgement to source, that acknowledgement must contain a specific number which is called acknowledgement number. So acknowledgement number defines the number of the next byte that the party expects to receive. It is cumulative. ACK is equal to 5487. This is an example to understand. What does it mean? It means it has received all bytes from beginning up to 5486. Destination has received total bytes which are 5486, and the destination expects the next byte which is 5487. तो एक्नॉलेजमेंट नंबर का मतलब ये है डेस्टिनेशन जो नेक्स्ट बाइट एक्सपेक्ट करेगा सोर्स से उस नंबर को हम एक्नॉलेजमेंट नंबर कहेंगे, और टोटल बाइट्स जो रिसीव हो चुकी होंगी उसके बाद वाला नंबर यूज होगा. जो टोटल बाइट्स रिसीव हो चुकी हैं डेस्टिनेशन को वो 5486 है, और जो नेक्स्ट बाइट एक्सपेक्ट करनी है डेस्टिनेशन ने वो 5487 बाइट है. सो एक्नॉलेजमेंट विल बी सेंड of 5487. TCP features. So dear students, we will discuss three main features over here: flow control, error control, and congestion control. First of all, what is flow control? Receiver of the data controls the amount of data that are to be sent by the sender. Numbering system allows TCP to use byte-oriented flow control. Basically, when the sender will send data towards receiver, the receiver has some limited capacity or buffer size. If that capacity is filled, next data bytes can't be received by receiver, so TCP provides the feature of flow control. Second is error control. Considers a segment as a unit of data for error detection. In TCP header, we have read about a specific field which was checksum. So checksum field is used for error detection. So TCP provides error control as well. What is congestion control? When the network is congested, then the sender will slow down the data transmission. In this way, data will not be lost. So TCP also provides the feature of congestion control as well. Connection establishment. First point, establishes a virtual path between the source and destination. Dear students, you know very well that the data is transmitted between source and destination on a physical media or wireless media. Physical media is wired media, that may be twisted pair cable, that may be coaxial cable, or that may be fiber optic cable. But on that specific physical path, physical media, different logical connections are created, and one logical connection, one logical path, one virtual path is assigned to a specific user. So TCP is used to create those virtual paths. Second point, how TCP is connection oriented while using IP, which is connectionless. Connection is virtual. TCP uses the services of IP to deliver individual segments, but it controls the connection itself. IP is unaware of retransmission out of order segments. Students, 80+% of internet traffic is dependent on IP. IP is itself unreliable protocol, but TCP is reliable protocol, and TCP with the help of IP or with connection IP provides data retransmission and in order data segments transmission. So TCP is reliable protocol and it provides retransmission. IP is unreliable protocol which does not provide any kind of retransmission or in order data segments delivery. Connection establishment. This concept is also called three-way handshaking, in which client will request to establish a connection to server. Server will respond towards client with acknowledgement as well as synchronization, and when the acknowledgement is received from server to client, the establishment of connection will be done, and after that data will be transmitted. We will see next slide. So over here in this diagram you can see there is a SYN packet from client to server. This is synchronization packet, or this is request to open a connection, and server will respond with SYN as well as acknowledgement, and when acknowledgement is received, then the connection will be established and the data transmission will be started from specific device. Connection establishment. As in the previous slide, we have seen a diagram for the process of connection establishment. In this slide, there is a detail of that diagram. First is SYN, synchronization. It is for synchronization of sequence number. It consumes one sequence number. So this was first step in which connection establishment request was done, and it consumes one sequence number, which means this requesting byte will be assigned a specific sequence number. We have discussed about sequence number in our previous slides. Second point, SYN plus ACK, synchronization plus acknowledgement. Synchronization segment for communication in other direction and acknowledgement for the received synchronization. Acknowledgement and synchronization will be in other direction means from sender to receiver, from server to client, and this also consumes a specific sequence number. It means this byte will also be allocated specific sequence number. Next is acknowledgement, which is from client to server side. Note, dear student, that this specific acknowledgement byte can't be allocated to specific sequence number. Just this is an acknowledgement segment, does not consume any sequence number, and after this acknowledgement segment, data transmission will be started, and for specific duration when the data is transmitted, this connection will be on until this connection will be disconnected. Connection termination, three-way handshaking. In this slide there is again a diagram which shows the process of connection termination. As we discussed in the previous slide, that when the connection will be established, when the data will be transmitted, after that connection must be terminated or disconnected. So from client to server there is a fin which is finished byte, and from server to client finish plus acknowledgement, and from client to server again this is acknowledgement byte, and in next slide we will see in detail about this diagram. Connection termination. So dear students, this is our last slide of today's lecture. As in the previous slide we have seen a diagram. This is more detailed discussion about that diagram. First point is fin, which is finished. It consumes one sequence number, may or may not carry real data. As we have seen in different slides of today's lecture, that every byte which will be transmitted from source to destination must contains a specific number. So this fin request will also contains a specific sequence number. For example, if you have opened Gmail account, when you will request to close that account, the request will be carried by this fin byte. Next point is fin plus acknowledgement. Fin finish segment to announce closing of connection in other direction, and acknowledgement for the received fin. It also consumes a sequence number. So this fin plus acknowledgement will be from server to receiver or server to client, which is authentication process to close the specific connection which is opened by client. And the last one is acknowledgement. Just an acknowledgement segment does not consume any sequence number. So this acknowledgement will be a green signal to terminate or to close the connection. So in this way, when a user or client will open a specific connection, then data will be transmitted, then that connection will be terminated. So TCP is a connection oriented protocol which is based on error control, flow control, and congestion control mechanism. So dear students, after delivering lecture in a class, the teacher say to ask the questions, but as you know that now we are in different online education system, So this is not like possible to ask the question in that manner, but you are always welcome to ask the questions, to post your questions, to post your queries using your Google Classrooms. So try to read your lectures carefully and post your questions so that you may be able to learn all the lectures in a very good way. So dear students, thank you very much for your concentration, for your learning, for your passion. I hope best of luck for all of you always.